Thanks for joining this training meeting for Architectural Student Contest 2025. So let me introduce myself. I'm Erwan Baquet. I'm working in EGR Compiègne, which is one of the transversal LD center. So many based in Compiègne. I'll share my screen. Okay. So we are dedicated to research topic on glazings, focus on manufacturing processes and product and processes. We are close to 200 collaborators based in Compiègne, so close to Paris. And today we will introduce some technical topics about glazings and glazing performances and safety performances. First, I will let Guillaume introduce himself and start to speak about visual comfort, energy performances. So, see you soon.
Hello, so I'm Guillaume Pendron. I'm in charge in EGR Compiègne, same center as Erwan, of the thermal and visual comfort team. So I will be talking to you now about these two aspects. And here is the start, which might seem a bit silly. I'm going to ask you, what is a window? I've looked actually in the dictionary, and in the Cambridge dictionary, they say that a window is a space usually filled with glass in the wall of a building or a vehicle to allow light and air in and to allow people inside the building to see out. So there's nothing about protection from heat, nothing about protection for the sun, which is in architecture today, things that we have to think about. But it's not only the Cambridge dictionary. If you take other dictionaries, you'll basically see the same thing. In etymology, window in English comes from the Old Norse, from the words that mean wind and eye. And actually, in the old Germanic people's houses, windows were just unglazed holes, so the eyes of the name, that permitted wind to pass through, especially, for example, to reduce the quantity of smoke. So it's not really close to what we call a window now. And interestingly, in the Latin languages, a word like fenestra, which gives the name for windows in French, Spanish, Italian, etc., may come from the word faino, which means to cause to appear or to bring to light, and of course may therefore be related to the very different climate they would have in the Mediterranean basin. But basically, people agree that in the most important roles of window, you have the view out. So a window is used to see outside. So of course, the quality of the view is not something that is really easy to address for glass makers, but at least we know how to increase the quantity of view, which is basically the area of the glazed surface. Definitions in the dictionaries, we're talking about letting air in, and of course that's not the role of glass, but it is usually and traditionally the role of windows. So sometimes we had holes in walls, but in the history of architecture, we had holes in windows and ventilation systems integrated in windows, and now HVAC systems sometimes integrated in windows. But I think it's important to remember that there's a progressive decoupling of windows and ventilation that has been happening and is still happening, but I'm not sure we can say it's been finalized yet. So we're now talking to the other functions of window that are more related to glass itself. First, the visual comfort. Of course, all rooms need light. And in general, we prefer daylight. But the quantity of daylight and light in general that we need depends on the room function. We will want more light in offices, in living rooms, kitchens, schools, hospitals, stores, etc. And sometimes we want less light in other rooms like bedrooms, hallways, entertainment rooms, bars, hotels, warehouses. If you have too much light in a room, there's a risk of both glare and overheating. So in that case, you might need solar protection. If you have not enough light, then you will probably have less comfort and maybe sometimes lose productivity, and in which case it's good to have artificial lighting. Here in this slide, you see what we hope is a clear example of the impact of the window size. Here you have a bedroom with a small glazed area on the left and a larger glazed area, which increases the light autonomy from 43 to 70%, which means the time of the year that the room is lit enough, and therefore decreases the quantity of energy you spent on lighting to cover the periods where light is insufficient, which is a significant reduction in energy consumption here. So, of course, the size of the window has a direct impact on visual comfort and energy consumption. When you have too much light, as I said, you want solar protection. There are several ways to reduce the quantity of light. You might use fixed or mobile solar protection. This is the most common way, but you can also use darker glass, which has a low light transmission, or as we say commonly, LT. You might have glare, in which case you can reduce it by using shadings, curtains or screens. You can have also more technological products like diffusive glass, like PDLC, for example. It's a technology that creates a diffusing glass surface, which reduces glare. And you can play with the interior design of your room to avoid people to be put in front of the sun. For overheating, there are also several ways to reduce it. External solar protection, reflective internal solar protection, a glass including solar control glazing or HVAC system. So all these solutions have different impacts on the elements that are caused by too much light. So you have overall choice to make between the effects that you want to play on and the cost and the energy consumption, etc. If you want more information on, for example, how to calculate light transmission on glass, you can go on calumet.com and see what happens if you play with the glazing systems. If we now jump to energy performance, just need first to remember that windows represent a significant part of the thermal losses of the building, but also a very big part of the thermal gains. Indeed, a window is always a balance. On one side, you have the solar heat gain coming, of course, from the sun, and that is represented by the solar factor or G value of the glazing. And a balance between the G value and the U value, which is, especially in winter, the global heat loss through the glazing. In winter in general, you want to increase the solar heat gain to reduce energy consumption and decrease the heat losses. So how to reduce the heat losses in the window? So you have this U value, which is for a single pane of glass of about 6 watts per square meter and per Kelvin. If you improve your window performance by using a double glazing, for example, with a rare gas like argon, then you create an insulating gas layer that will reduce the losses through the glass. That will, for example, in this case, reduce from 5.8 to 2.6 watts per square meter Kelvin. You create that by, of course, creating this static gas layer. The thickness will be optimum for argon for about 16 millimeter, like for air. Other gases might have different optimal thicknesses. You can also add to this double glazing a low emissivity coating. So this low emissivity coating will prevent the heat being transferred between the two glazing panes by radiation. The main parameter of this phenomenon is the emissivity of the low coating. And if you decrease the emissivity to the minimum values that we can reach, which is almost 0, then your U value for double glazing may decrease to about 1 watt per square meter per Kelvin. But this is basically the limit of the double glazing technology. So to still improve the thermal resistance and decrease the U value, then you need to go to triple glazing unit, like in this case for which is basically an optimum product, triple glazing with 90 millimeter cavities and argon in the 2 cavities. You can go down to about 0.5 watt per square meter and per Kelvin, which is at this point equivalent to an insulated wall. Maybe not a very insulated wall, but it starts to be quite efficient. Be careful that if you think about using a triple glazing unit, if you don't add the Loic coating, it's less insulated than the double glazing unit with Loic coating. So if I come back to what I was saying earlier, windows and glazings are always playing a role of balance, but the balance between elements that might be different depending on the region you're talking about. For example, in the very cold climates, what you're trying to optimize is increasing the solar gains and decrease as much as possible the losses and the U value of the glazing. In an intermediate climate, like for example in the UK, you're trying to get a balance between the thermal insulation and the solar gains by having not a very high solar factor, but a moderate solar factor, because you don't want excessive heat in the summer, which can be a very big problem. In a hotter climate, for example, Mediterranean, you will balance between winter and summer solar gains. So you're looking between a lower and a moderate solar factor to try to strike this balance. Whereas in the very hot climate, you will try to balance the need for natural light and the need to reduce the solar gains that come with them. So you might play with the glazed area, find the lowest possible solar factor values, etc. As you can see on the right, the distribution of energy consumption between cooling and heating and the yellow part is lightning, really depends on the region you're talking about, depending it's a cooling or heating dominant climate. So for this example here, I will leave the floor to Erwan again.
Yes, thanks a lot, Guillaume, for clear and complete explanations. So as a conclusions of the previous talks, some example of what we could advise for you for both topic, which is village of Chimila, for the first buildings to be studied on this contest. We advise a triple glass unit with a UG value below 0.8 watt per meter square per Kelvin. You will find some commercial name as Climatop or Climatop Protect, which is an additional protection for safety. We'll speak about it later, including a limited glass for safety of people. Or a third version can be a Climatop Protect Silence, which also include a special interlayers, will be discussed later also, which improve acoustic property of the system. For the solar factor, as explained by Guillaume, which is important because of localizations of Chimila in between two areas, we advise a solar factor below 50% to reduce solar gain, but not too much, by using two kinds of product, which is E-class Zen or E-class Sun. You will find the link below on the right. For the other area, which is Les Grands Ateliers, which is a new buildings, tertiary buildings with bigger glass pane, we think. We advise also to use a triple glass unit with UG value, again, below 0.8 watt per meter square per Kelvin, and two type of product, Climatop Protect, which is a safety glazing unbended, or a Climatop Protect Silence. Again, the solar factor have to be below 50% again, with a reinforced solar control because of big glass pane and big glass surface, and we advise to use a coated glass like SKN 7033 for optimum performances.